Okay, ladies and gentlemen, today's notes are, we're talking about circles. So today we're discussing arcs and angles. Arcs and angles. Now, everyone should have received the arcs and angles notes. It's a graphic organizer. It looks like, no, it doesn't look like that. It looks like this. So have that out. Before we start filling this in, we're going to talk a little bit about some vocabulary. So first, vocabulary. What is an arc? So if I have a circle, here's my circle. And I have the center of my circle. All right, here's a central angle. So my first vocabulary word is central angle. And a central angle is really easy. It's just an angle that has its vertex on the center of the circle. So I'm going to say vertex is on the center of the circle. Okay, so here's a central angle. Now, we're going to look at a couple of things in a second, but one thing that happens is this central angle has a measure, and it ends up being the same as the measure of this arc. So we can measure arcs in degrees, just like we can measure angles in degrees. So these end up being the same. We're going to talk more about that later. But let's say this angle measures, I don't know, let's say 58 degrees. Well, that means this arc also measures 58 degrees. If these are my endpoints, let's call this A and call this B. I would label this as arc AB. So when you're labeling an arc, labeling arcs, you label a minor arc with 2 points and the little arch over top, and you label a major arc with 3 points. So this arc here, we would say AB, and I could say that the measure of arc AB equals 58 degrees. Why would I say this is a minor arc? What's the difference between a minor arc and a major arc? Well, a minor arc has a measure less than 180 degrees, and a major arc has a measure more than 180 degrees. So I'm going to say minor arc measures less than 180 degrees, and a major arc measures more than 180 degrees. When we label a minor arc, we only need 2 letters. Okay, when I say arc AB, you automatically know that it's this part here, okay, that I'm talking about. Oops. This part here from A to B. So labeling arcs, minor arc, label with 2 points. A major arc, you need 3 points, because if I say arc AB, well, how do I know if I'm talking about this part or, oops, undo. Okay, this part or this part. So to specify that I'm talking about the larger arc, the major arc, I need to include a 3rd point. Let's call this point C. So I'll say major arc measures more than 180 degrees, label with 3 points, okay? And my example is from major arc, or from minor arc, we have arc AB with a little arc over top, and that was this one that we had highlighted in green, or blue, whatever color you think that is. And then we have arc A, C, B, and that we have done in yellow. And notice the order that I put them in. We go from A to C to B. If I talk about A, B, C, I'm talking about a different arc. You have to pay attention to the order that they're written in. So we've got central angle, that's our angle we have here. We've got labeling arcs, minor arc and a major arc. So I said minor arc measures less than 180 degrees and a major arc measures more than 180 degrees. So what happens if it equals 180? What do we call it then? Well, then we call it a semicircle. So a semicircle is half of a circle. So the arc measures 180 degrees. Okay, so there's our semicircle. Now, okay, let's go to our chart now. Here it is. Those were, okay, do you want to keep swearing on or this one? Keep on. There we go. Okay. So, first, there's different relationships between the angles in a circle and their arcs. The first one, we've got our first column, says location of vertex. So, if the vertex is on the edge, I'm going to draw my picture first. It looks something like this. Okay, I can also have the vertex on the edge and have it look like this. If we have this first situation, then the angle has a special name, and it's called an inscribed angle. So this is an inscribed angle. This one here has no special name. Okay, when the vertex is, or the angle is entirely inside the circle, has its two endpoints on the circle, it's called inscribed. We already talked about the word inscribed in relation to polygons. So this is an inscribed angle, and here's the picture. Now, let's look and see what happens. So I'm going to open up Geometr Sketchpad for a second, and I'm going to draw a circle here. So here's my circle, and I'm going to make an angle whose vertex is on the circle. And we'll make it an inscribed angle. So these edges, these endpoints here are on the circle. Now I'm going to measure this angle. Measure angle. And it says that measure of the angle is 61.27 degrees. Well, I'm going to measure this arc also. Measure... I think I need to construct first. Construct arc. Okay, and now measure arc angle. Okay. So here's the measure of this arc, 122.53 degrees. So what do you think the relationship is? As I move this, let's see if I can get this to be 70 degrees exactly. just about. So what's the relationship between this and this? Well, the arc is twice the angle. Doesn't matter where I move this, the arc is always going to be twice the angle. Okay, oops. I've moved it past D, that's why I kind of messed it up. All right, so this always works. You can make it really small, make it really small. It still works. Okay, the arc is always twice the angle. So I'm going to minimize this. I'm going to come in here and I'm going to write my formula. So my formula says that the arc is twice the angle, or you can say the angle is half of the arc. So I'm going to write angle equals 1/2 arc. Okay, angle equals 1/2 arc. And an example problem. So let's say I have this circle here. Here's a problem. Let's say this angle is 45 degrees, let's say 44 degrees. What's this angle here? I want to know what's the measure of its intercepted arc, which would be this one. Well, the angle is half the arc, so if I substitute it into the formula, 44 equals 1/2. I'm going to call this x. If I multiply by 2 on both sides, I get that x equals 88 degrees. So that means that this green arc here measures 88 degrees. So the angle is half the arc when the angle is on the circle. The next one. So the next one we already discussed a little bit. If the vertex is on the circle, or on the center, I'm sorry, it looks like this. This is called a central angle. We already defined this. Central angle. This is what our picture looks like. So that's a central angle. Now let's look at our geometer sketch pad to kind of see how that plays out. So I'm going to delete these. Delete that. Delete that. Okay. Let's just delete it all. Oops. I don't want to close it. Sketchpad file. I want a new one. What's going on here? Okay, I'm on SmartInk. Sorry. All right, here we go. So, sorry about that. So here I'm going to draw a circle again. Here's my circle. This time I want a central angle, so my angle has to have its vertex on the center. And I'm going to measure this. Measure angle. And then I have to, let's see here, delete. So this angle goes here. Now I want to measure my arc. So my arc goes from here to here. So I want to construct let's see here. Let's add another point. 1, 2, 3. Construct arc. Okay. So now I'm going to go measure arc angle. So here's my arc angle. And this one's pretty easy to see. As I move this around, what happens to the angle and the arc? Well, they stay exactly the same. So here we have minor arc, minor arc, minor arc, and then it becomes a major arc. Still Oops, still these are the same. When I move it over here, it messes it up a little bit because of how I have these labeled. But it's always equal. Okay, so the point is that the central angle equals its intercepted arc. So my formula would be simply that the angle equals the arc. So I have a simple picture here. Here's my picture. My angle's on the center. Let's call this angle X, and let's call this 95 degrees. Well, it's super easy. X equals 95 degrees. Okay, these are very simple examples, but you'll see some more complicated things in your homework. Now, the vertex is outside the circle. There's no special name. Okay, there's no special name if the vertex is outside the circle. But the picture looks like the following. Okay, something like this. Now, when you're dealing with a vertex outside the circle, you have to think about these intercepted arcs here. So in this case, we have two intercepted arcs. We have one that's larger than the other one. This far one will always be larger than the other one. And what happens is that the measure of the angle equals the big arc minus the small arc, all divided by 2. So big arc minus small arc divided by 2. That's what happens here. You can see that in Geometer Sketchpad, but it's a little bit harder to figure that out yourself. If I draw a circle, and let's make a point, oops. I'm going to make a point here, and a point here, point here, and a point here. Okay, so I want to measure this arc. This is the big arc. Measure angle. Oops, I don't want to measure angle. Undo, undo. I want to go construct arc, and then I want to measure arc. But not the length, I want to measure the angle, arc angle. Okay. And now here, I'm going to do the same thing. Construct. Let me do this. Construct arc through points, measure arc angle. So we've got this little guy measures 40. This big guy measures 132.33. And now I'm going to measure the actual angle. Measure angle. Okay, so here's my angle measure. Here's my small arc. Here's my big arc. Let's see if we can get these to be some even numbers. It's kind of hard. All right. So if I have this, then we've got 152.4 big arc minus small arc, which is 47, all divided by 2. 152.4 minus 47, 152.4 minus 47, and then if I divide it by 2, I get 52.7, which is what we have over here. Okay, so they end up equaling the same thing. So the point is it's big arc minus small arc divided by 2 if the angle's outside of the circle. And it doesn't matter if you're touching with a tangent or a secant or two tangents. It's always if the angle's outside, big arc minus small arc divided by 2. So that's that. So here's our example. let's say I have a circle, and here's my angle outside, and let's say this is let's say this is 120, let's say this is 40. I want to find the measure of my angle. So the angle equals big arc, 120, minus small arc, and these should all be degrees, divided by 2. So 120 minus 40, that's 80. 80 divided by 2 is 40. So our angle is 40 degrees. Okay? There's your simple example. Now, the last one is if the angle is inside, but not on the center. So what you end up having is like an X, a crisscross. And there's no special name here either. No special name. But our formula ends up being very similar to the first one, but this time it's that the angle equals big arc plus the small arc divided by 2. So if we take, let's say I want to find, here's my example, crisscross. So I want to find this angle here. And I know this is 70, and I know this is 20. So I know that my angle equals 70 degrees plus 20 degrees divided by 2. Well, that's 90 divided by 2, so that's 45 degrees. And that would be the measure of my angle here. So we're taking this arc plus this arc divided by 2 will give you the angle. Here it was this arc minus this arc divided by 2 gives you the angle. And the way I remember that is that this crisscross in the middle kind of looks like a plus sign. So I remember this is the one that has the plus, and then this is the other one has the minus. Okay? And those are all your notes for today. So you guys should be able to finish to work on those exercises that go with arcs and angles.